Hello everyone, welcome to the CS Revelation. In this video, we're going to take a look at some of the most famous crypto systems and then implement them using Java. So first, we're going to explain and describe all the different steps throughout the encryption and decryption process for these crypto systems, and then we're going to turn them into Java applications. So what is crypto? Now, crypto simply is the science of secrets, and literally it means hidden writing. Now, crypto is a method of hiding and protecting information by using a code or a cipher. Now, today, modern cryptography is essential to the secure internet, corporate cybersecurity, and of course, blockchain. However, the earliest use of ciphers dates back to around 100 BC. And the first cipher that we're going to take a look at is called the Caesar cipher. We say Caesar cipher or the Caesar crypto system. So cipher means crypto system or algorithm that is going to be used for encryption and decryption. Now, the Caesar cipher is one of the earliest known ciphers, and it's developed around 100 BC. It was also known that is used by Julius Caesar to send secret messages to his generals in the field. And in the event that one of his messages got, let's say, intercepted by his enemies, uh, these enemies could not read them and could not decode them. This is obviously gave him a great strategic advantage. So what was that code? So we're going to explain what that code is. Also, we must also mention that the Caesar cipher is a substitution cipher, and a substitution cipher means that the plain text or the message that we're going to encode has some characters. These characters will be substituted with new characters. And that is the process for the encryption, which is substituting the original characters with new characters. That's why it's called the substitution cipher. It is also called a shift cipher. And we're going to take a look at an example, and that's definitely going to help us understand how the Caesar cipher works. So this example says ROT13, which means that rotation 13. And what we really mean by that is that we're going to be shifting, we're going to shift 13 characters in this alphabet. So first, you're going to start by creating a grid. On this grid, you can have one row for the alphabet, the regular alphabet, and that is A through Z. And you will have a plain text that you're going to be encoding, and of course, a key, which is an integer number that's going to be used to decide on the number of characters to be shifted. So the key here says 13. That is just an example. What that means is that we're going to count 13 characters, and those 13 characters will be shifted back to the end of the alphabet. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are 13 characters. We're going to create our new alphabet that is going to be used for the encryption. That is going to be called the Cipher alphabet. And that is by shifting these 13 characters and then, of course, starting our new alphabet with the character N. So A through M is 13 characters. We're going to shift them to the back of the alphabet. And we're starting alphabet with N because it's character 14. Okay, so this is called the Cipher alphabet. And this is the plain alphabet. Now, our goal is to generate the ciphertext, means we're going to encrypt this plain text and turn it into ciphertext. So the process is very simple, is that you take each one of these characters one at a time, and you're going to find a match for it in the cipher alphabet. So you start at the plain alphabet, and then you match it with characters from the cipher alphabet that you just generated. So the first character here is A, and it's matched with N. So therefore, the first character A is going to be turned into N. And then we have the character T. T is right here in the plain alphabet, and is going to be turned into G. And G is the character that is going to be the one to substitute T, and that is our second character. Of course, the third one is T, so therefore it's going to be turned also to G. The next character is A, and we figured that A is also N. And then we have C. So C in the plain alphabet is matched with P in the cipher alphabet. And then we have K, and K is matched with X. So K is matched with X. Now we have space here. It is recommended not to include spaces, but if you include spaces, make sure you add, let's say, a special character to represent that space. But it is recommended to eliminate spaces before encoding. So now our next character is A, and A is aligned with N. So the next character is N, and then we have T, and T is aligned with G. And then we have D, and D is aligned with Q. And then we have A, and it's aligned with N. And then we have W, which is aligned with J. And then we have N, which is right here, and it is aligned with A. So by following that process, which is generating the cipher alphabet, which is based on this key, which is an integer number that's going to tell us how many characters are we going to be shifting. So we shifted 13 characters to the end of the alphabet, and that generated this new cipher alphabet. And the next step was to really match these characters from the plain alphabet to the cipher alphabet based on their alignments, column by column, character by character. And this gave us this cipher text, which if, let's say, intercepted by the enemy back at the time, they're not going to be able to figure out what this really means because they don't know that there was a cryptosystem or a cipher that was used to turn this message into this cipher text. And also, even if they knew the cryptosystem, which is the Caesar cipher, they wouldn't know the key because the key is a shared secret key between the sender and the receiver. But once this is compromised, of course, they will be able to decode this message and know the plain text. Of course, this could be broken, this cryptosystem, because you could basically, if you don't have the key, but you know the cryptosystem, you could try like 26 possibilities, 26 keys, because you have 26 characters here in this alphabet. That means there are 26 possible shifts. So it is possible to decode this once that you have known the cryptosystem, and in addition, that you knew it's 26 characters in this alphabet. So therefore, it's going to be broken after 26 tries, maximum 26 tries. However, it's not easy without knowing the cryptosystem and the key. So this was a description of how the encryption really works with the Caesar cipher. And let's take a look how we can do the decryption, right? So let's assume that the cipher text that we were given is this, right? So we were given this cipher text, and we're trying to decode it and turn it into a plain text. So our goal now is to turn that cipher text into the plain text. So let's assume that we haven't seen the process of encryption there. So now we're doing decryption. So you're given this. The person who is receiving this message, he's going to be receiving this cipher text, right? So this is cipher text. And that person also has the key, which is 13. It's a symmetric key. It's called symmetric key. The sender and the receiver, they have agreed on that shared key. They both have that key. They both know that key. Only those two people will know the key. So that same key is going to be used for encryption and decryption. So the same process here is that you start by putting the alphabet, the plain alphabet, A through Z, and then looking at the key, we're going to generate the cipher alphabet. So there's a 13, therefore we're going to shift 13 characters to the end of this alphabet. That's going to do that, and then we're going to put the rest of the characters at the beginning. So this is going to give us what we call the cipher alphabet, right? So this is going to be our cipher alphabet. Now, by doing that, you basically have performed the first step. And the second step is to do the opposite of what we have done earlier in the encryption process. We are not going to be going from plain to cipher, but you're actually going to do it in reverse order. So you're going to go from cipher alphabet to plain alphabet because you're doing the inverse. You're not encrypting, you're decrypting. So now let's try to follow that process. So you're going to take the first character, which is N, which is right here in the cipher alphabet, not this one. Okay, don't confuse it. So it's this one from the cipher because you're going from ciphertext to plain text. Therefore, you go from ciphertext to plain text. So the first character here is N, and N is going to be turned into A. Okay, so the first character here is A. And then the next character is G, which is right here, is going to be turned into T. Okay, so we have T, and then we have another T. And then we have N, N is A. And then we have P, and P is going to be turned into C. And then we have X, and X is going to be turned into K. And then we have N, and N is going to be turned into A. And then we have G, and it's going to be turned into T. And then we have Q, and Q is going to be turned into D. And then we have N, and it's going to be turned into A. And then we have J right here. It's going to be turned into W. And then we have A, the last character, which is right here. And it's going to be turned into N. So we just decoded this and turned it into this plain text. And there you go, attack at dawn, right? So you basically can decode or decrypt this message by using the same symmetric key that is shared by the sender and the receiver, and by following the process of generating the grid that is composed of the plain text alphabet and the cipher alphabet. And of course, you're going to match the characters one character at a time, but going from cipher alphabet to plain alphabet, and you will be able to decode it. So now that we have seen the process of encryption and decryption using the Caesar cipher, our next task is to implement this algorithm and turn it into a Java application. So let's take a look at that. Okay, so to implement the Caesar Cipher crypto system, we're going to need, I'm using NetBeans for my IDE, and for this, first of all, let's put down what we need. I need two methods. I need one method that I'm going to use for encoding and one method that I'm going to use for decoding. So let me, first of all, put that down. So public static, let me make this return a string value. And this is going to be the encoding. Okay, so this is an encoding method. Okay, so this is my first method. And my second method is going to be for decoding. So same thing, public static. And this is also going to return a string, which is basically the decoded string. So this is decoding, and let's see. So now we're going to take a look at how we can implement each one of these. So we know that we need two methods, one for encoding and one for decoding. Okay, and now we're going to take a look at the process of encoding and the process of decoding. Before we begin with any of these processes, first we need to declare a global string. This global string is going to be our alphabet, right? So I want to make that global, so each one of these methods is going to be able to have access to it, so it's not a local variable. So I'm going to make this a static as well. So static string alphabet, and I'm going to make it equal to the alphabet. So it's a string that contains all the characters that make up the alphabet. So A, B, C, D, E, N, oh, wait. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So now we have our string alphabet, which is composed of all the characters that make up the alphabet, 26 characters in total. That's done. And now we're going to start by defining the encoding scheme, right? So how is the encoding really done or performed? First of all, we should know that our encoding method needs two things. Like we did earlier in our example, we needed a plain text so we can encode, and also we needed a key so we know exactly how many characters are we going to be shifting. So therefore, the parameters that this method is going to take are the inputs for this method. So first we need the string plain text, right? And then we need a key, which is of type integer. Okay, so now that we have define our parameters, our method is going to need a plain text and needs a key, okay? The next thing that we want to do, because our alphabet is in lowercase and we want to be consistent with that, and we cannot predict what the user is going to give us as plain text, whether it's uppercase, lowercase. So by default, we're just going to turn it into uppercase. So whatever we get from the users, whatever they type in as their message to be encoded, we're going to be turning it into lowercase. So to do so, though, we're going to say the plain text that we got from the users is going to equal to ptext dot to lower. So we have this function that is to lowercase by default given by Java. That's going to turn our message that the user will input to lowercase. All characters will be turned into lowercase. And then, of course, like our goal is to return the ciphertext after the encoding process. So let's declare the variable that's going to be of type string, in which we're going to be saving our ciphertext and, of course, return it. So we're going to return ctext. That is the ciphertext. So the process here is that first we will turn it into lowercase, and then we declare this variable, but by default we initialize it to empty string. And here we're returning the ciphertext because we said this returns a string, therefore this is going to return the ciphertext, which is going to be of type string. But we haven't generated that ciphertext yet, so here's the process of doing that. So first we need a for loop to loop through all the characters of the plain text that we're going to be turning into a ciphertext. So we need a for loop that has that starts at 0 and it's going to loop through all the characters. Therefore, is going to be I is going to be strictly less than the plain text length, right? That length. So we want to go from the first index, which is 0, to the up to the length, which is the size minus 1. That's going to be giving me the last index of that string. And of course, I plus plus. Okay. And the first thing that we're going to do when we're looping through these characters of the plain text is that we want to first get the indexes of each one of those characters. So if the text, let's say, is hello that we're trying to, encrypt, I need to know the indexes of each one of those characters, H, E, L, L, O. I need to know their indexes in the alphabet, right? So I need to know the indexes of H and index of E and L. And why do I need that? Because I need to know the index of H, so I know because I know the key is, basically by how many characters I'm going to shift. So I'm going to take the index of H, and I'm going to add to it the key value, which is going to be the new index that I'm going to be using. So let's take a look at how is that done. So first I'm going to say int, for example, the character index, right? So this is the variable that I'm declaring, which is the character index, the current character index. How do I get that? So it's basically the alphabet dot index of, that's the function that's going to get me the index of course, the plain text dot char at I, right? So because we're looping through all the characters in this plain text, we would like to know the index of each one of those characters in the alphabet, right? So if it is H, let's find out its index in the alphabet. If it is E, let's find out its index in the alphabet, and so on. So, and that index is going to be stored in char index. And next, we want to generate a new index, which is the shifted index. So it's going to be, I'm going to call it new index. And I'm going to make it equal to the current character index, which is char index, and that is plus the key, which is the key value, that is the shift value. Okay. So now that I have done that, I actually need to do something else. Just in case, let's say the key is, not within the margin of 0 to 26. That's my alphabet. Let's say like the person wants, key 56. Then we should do mod 26, which is going to basically turn it into a legitimate key that is going to be between 0 and 26. And then we're going to now generate the cipher characters. So I'm going to say cipher, let's say char. Let's say, because we're looping, that means we're going to do this for every single character in our plain text. We're going to do alphabet dot char at wait, dot char at wait, why am I doing that? Alphabet dot char at, right? Char at new index, right? Because I generated the new index for my cipher character. So therefore, I'm going to try to get the character from my alphabet that is at that new index. So this basically tells me, all right, H is at index, for example, what is it? 0, 1, 2, 3, 4, 5, 6, 7, right? So H is at index 7. And if my, let's say, shift is 5, right? Let's say the key is 5, it's going to be 7 plus 5, right? So it's going to be 7 plus 5, that is 12. Therefore, let's find out the character that is at index 12. And that's going to be the character replacing H. So this is character at index, so we said 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So L is going to be, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So M is going to be the character that is going to replace H, which is in my hello plain text. So we're going to do that one character at a time, and we're going to append those characters into the string ctext that we created earlier. So we're going to say ctext concat is going to be equal to ctext plus the cipher character that we just figured out in the previous step. Which means that we're concatenating all these characters that we're going to find because we're looping. So again, whatever character we find, we're concatenating it with the contents of ctext. And then once that's done, we're going to return the ctext. Okay, so this is the complete encoding method here. So this method is going to do the encoding for me. It's a pretty simple process which depicts the same idea we took a look at earlier in the description for what the Caesar cipher is. Earlier we're just doing it by hand manually, but this one is basically turning into instructions that will be executed by the Java compiler. All right, so now that we've created this method, let's take a look at how we can create the decoding method. It's probably almost the same as the encoding, except that it's in reverse. And there's one more thing, which is to handle negative values as well. So the same thing, we're going to turn into lowercase, of course. This, first of all, takes two parameters, decoding. What's it going to decode? It's going to decode the ciphertext. So we know we need the ciphertext that we're going to decode. And we need the key, right? Because the key is going to be used for encryption and also decryption. So we need the key as well, which is an integer value. The first thing is to turn ctext into lowercase. So we're going to say ctext is equal to ctext dot to lowercase. That is just to be inconsistent. I mean, to be consistent with the alphabet format, because the alphabet is in lowercase, so we need to turn our ciphertext to lowercase as well. The next thing we want to do is also to declare a variable of type string, and that's going to be my plain text that I'm trying to generate here because I'm trying to decode, means decrypt, means turning a ciphertext into a plain text. And after I'm done, I'm just going to return that plain text. Okay, so this is like, do this, turn it into an uppercase. Once you get the plain text, just return it, right? Because this method returns a string. But we need to come up with that plain text. So let's see, let's take a look at the process. Also, we're going to need a for loop that's going to loop through all the characters of the cipher text that we're trying to turn into a plain text. So I equals 0, and then I must be less than, of course, the c text dot length, right? And we're doing I plus plus. And the first thing that we're going to do within this looping process is to generate, like we did earlier, we're going to generate the indexes of the characters that we have in the ciphertext. And we're going to find their indexes in my alphabet. So for example, if the character is D, I want to find out the index of D in my alphabet. And then once we find that index, of course, we're going to subtract the key, which is the shift, and then we're going to generate the new index that's going to be the plain text character index. All right, so first is going to be int char index. So we want to get the index of the characters. That's going to equal to the alphabet dot index of, right? And it's the index of ctext dot char at I, okay? Means whatever the values of I, because we're looping through all the characters of the ctext. Let's get the indexes of all those characters, okay? And then once we have found those, we're going to generate now the new index. The new index, that's the index of the characters that will be in the plain text. So that's going to equal to, of course, the char index that we generated earlier minus, of course, we're going to subtract the key, right? So we're going to subtract the keys, capital K. And of course, we're going to do mod 20, what is it, mod 26 as well, because we have 26 characters. And that is to do that. And of course, we need to test if we have any negative values. So therefore, we need to say if new index that we just came up with, because we're subtracting here, right? And subtracting, if the key is higher than the character index that we found, we may end up with a negative value. And of course, there's no negative index. So therefore, we need to do something about the negative indexes. So if it is strictly less than 0, then we should add the following. So we should say new index should equal to alphabet dot length, right? So which is basically 26 plus new index. So if, let's say, like The new index is supposedly -5, right? Because, the key value is greater than the indexes. If it's -5, we're going to add that -5 to the length. So 26 plus -5 is going to give us 21, right? So that's going to basically turn it into a legitimate index. That's to prevent the negative values, okay? And then, of course, we're going to generate the plain characters. So the plain char is going to equal to the alphabet dot char at, it's always not giving me. So char at is going to be char at new index. So we want to get the characters at that new index that we found. That character is, now that we found, we're going to append it or concatenate it with the rest of the characters in my plain text. So I'm going to say ptext is now going to equal to ptext, which stands for plain text. Okay, spell it right. Is concatenated with the plain character. Of course, this is going to be a list of characters, and that's why we are concatenating them here. And then once we're done, we're going to just return them. Again, this is the process of decoding, which is pretty simple. And this is just one way of doing it. There are a lot of other ways to do the same thing, except that this is just one implementation of it, which is find out the index of the character. If you're encoding, you're going to add the key to that index, so the key value, which is the shift value to that index, and find out the character that is at that new index. And that's going to be your cipher character. And if you're decoding, you basically find out the index of the character in my ciphertext, subtract the shift value, which is the key value, and then find out that character that is located at that new index that we just figured out. So this is encoding. And this is decoding. I will be sharing this code with you. I'll post it below in the description. So if you feel like, I'm not sure if this is going to be allowed to be shared down in the, I will provide you with a link where you can get a copy of this code. Now that we created our methods, right? We created the encoding method and decoding method. Now it's time to use them, right? And where do you use them? You use them in the main method. So maybe the first thing to do is to prompt the users to give you the plain text, and then you're going to encode that plain text. And then later on, you're going to decode that, and we'll see that process. But in order for you to prompt the users to input any of these values, you need a Java scanner. So I'm going to do just, let's say, scan equals a new scanner. So we're instantiating the scanner class by creating the scan object. So this is a system.in. And the first thing that we're going to do, first we need to import the java.util scanner. So the first thing that we want to do is to output a prompt message. That is to system out print. Okay, so we're going to print the message, the prompt message. So for example, enter plain text, right? So enter plain text. And of course, after prompting them for that, we want to use the scanner to get that plain text. So I'm going to declare a variable of type string that is going to be, let's say, plain. I'm going to call it plain. Equals, through the scanner, it's going to be a .next. Of course, because we are not allowing spaces, you can use a .next. If you're allowing spaces, you can use the .next line, right? So it's really up to you what you're using. I'm going to use the .next line. However, you can use either one, depending on what you want to accomplish. And the second thing is a prompt message for the users to ask them to type in the key, because you need the plain text, and also you need the key. So you're going to say enter key. And of course, you're going to collect that key. That key is an integer value, so it's going to be int, let's say key equals, which is through the scanner dot next int. And now that we got those values that we need to pass to our function or method, our method is the encoding method. So it returns the ciphertext. So we're going to use that method. So I'm actually going to declare a string value to collect the ciphertext. So I'm going to call this ciphertext. Okay, so this is my variable of type string. It's going to equal whatever the encoding method going to give me back. The encoding method takes two things. It takes the plain text, which is in this variable plain, and of course it takes a key. And the key is going to be the second parameter or ingredient. Let's test this out. So I can, actually before we test that out, we need to print that to confirm that we actually have generated a ciphertext. So I'm going to use a print line here, and I'm going to do, all right, just simply type the following message. The ciphertext is, or the encoded message, or the encrypted message is, and then we're going to concatenate it with this variable. Okay, so let's run it now. So when we run it, so here we're prompted to enter a plain text, right? So I'm going to type simply hello and press actually hello world. And then I'm going to press the enter key. And it's asking me to give a key, right? That's the key, the second ingredient, which is the shift. I'm going to say, let's suppose 8. Press the enter key, and then it says the ciphertext is this. And let's try this with attack at dawn, right? So let's say attack at dawn. And earlier we used a key 13, right? And it gave us the following ciphertext. Now let's add some code into the main method that's going to also use the decode method to decode this ciphertext. So for this, we're going to do the following. So we're going to say, so we're going to output a message saying, so we're going to say the decoded message is, right? And then what are we going to do? We're going to concatenate it with whatever the decoding method does. So the decoding method takes two things. It takes the ciphertext, which is in this variable, and it's going to also need the key to decode it. Okay, so this should print for me the result of the decoding or the decryption, right? So let's find out. So when we run this, it's going to ask me for a plain text. Actually, it says Palin. Well, I don't like misspelling things, so let's try to fix that so that it is plain. All right, so run it again. So it says enter plain text, and I'm going to say attack at dawn, right? And the key should be 13, and it says this is the ciphertext. And in the second line there, it's actually trying to decode this. And when decoding it, it turned it into this, which is attack at dawn, right? So it's telling us that our decoding and encoding methods are both working properly or the correct way. So again, this is the encoding method, and this is the decoding method for this crypto system, Caesar Cipher. Now, I'm going to end this video here because that is the end of this process. In the next video, you're going to see the implementation or the explanation of another crypto system. And of course, there will be a series of crypto systems, and stay tuned for all of those. And peace.